Hello, students. Please get your paper ready for notes. You're going to take notes on Unit 7, Lesson 2. Write this on the top of your paper. Put the title. The title is Powers of 10. And in parentheses, I want you to write base 10. I'm only talking about base 10 today. Pause the video till you're ready, and then keep up with me. Okay, let's practice base 10. And if you're not even sure what I'm talking about, base what? Just think back to our last class when we reviewed exponential notation. Remember that this is the base and this superscript number is the exponent. If you need to, just write that on your paper. The exponent is the superscript, or you can call that the power. And the larger number that's written normally, that's the base. All right. Now, what is 10 to the first power? Well, that just equals 10. Let's keep going and write notes on powers of 10. That's 10 to the first power. How about 10 to the second power? That's 10 times 10, and it equals 100. How about 10 to the third power? In expanded form, that's 10 times 10 times 10, and it equals 1,000. Pause the video and catch up. Okay, let's do another one. 10 to the fourth power. That is, in expanded form, 10 times 10 times 10 times 10, and it equals 10,000. Oh, are we going to keep going? This is exhausting. I can't keep writing it out in expanded form and then counting up how many tens I have. This is exhausting. What if my teacher gave me 10 to the 7th? Do I have to write that out 7 times? No. Now you can recognize the pattern. Every time you multiply by 10, you put on another 0. So 10 to the 7th, start with your base 10, and then multiply 6 more times to get 10 to the 7th. So that 10, the base 10 is 10 to the first power, and then 10 to the second power, 10 to the third power, fourth power, fifth power, sixth power, seventh power. Now just count back and put on your commas and you get 10 million. Let me show you again. 10 to the, I'll do something a little shorter now, 10 to the 6th. I want to write this out in standard form, but I don't want to write all the 10s and then count up the zeros. So here's what you do. Start with base 10. And then every time you increase the exponent, you add on a 0. So this is base 10. 10 to the first power. 10 to the first power. Now 10 to the second power. 10 to the third power, fourth power, fifth power, sixth power. There's the number in standard form. Now just count back and put on your commas. And you can see the number's 1 million. Okay, I'm going to show you an even faster way. Well, just look at the exponent, and that's how many zeros you have. So 10 to the 7th power, that's 1, 2, 3, 4, 5, 6, 7 zeros. 10 to the 6th power is 6 zeros. Look back. 10 to the 4th power. That's 4 zeros. The exponent on the 10 tells you how many zeros. This is true for base 10. All of these examples are, let me get the highlighter. This is important. This is not base 2. This is not base 1. This is base 10. 10, 10, 10, 10. This is true for tens, base 10. Okay, So every time the exponent increases, you know you are multiplying by another 10, so you add on another 0. I'm just going to do one more example. Let's say you had 10 to the 25th power, and I asked you to multiply that by 10. 10 to the 25th power times 10. What does that equal in exponential form? Well, if it's 10 to the 25th and you're multiplying by another 10, you're just going to put on another 0. But we saw that it increases the exponent one more time. It increases the exponent by another value, so this is 10 to the 26th. 10 to the 25th times 10 gives you 10 to the 26th. Let me write this again in another way to prove it's true. 10 to the 25th times 10. Now this 10 is to the power of 1, right? 10 equals 10 to the power of 1. And you already know from the last class that when you multiply the same base, you add the exponents. Remember? When you multiply the same base, you add the exponents. So add 25 plus 1. 10 to the 25 plus 1 equals 10 to the 26th power. What if I multiplied that by 10? 10 to the 26th power times 10 equals 10 to the 27th power. Oh my gosh, I got so excited about powers of 10. Please pause the video if you need to. And then I want you to turn to your neighbor and explain what you learned. This is important. Pause the video, finish your notes, and then turn to your neighbor and explain what you learned. You learned that every time you multiply a power of 10, you can add on another 0. And that the exponent on base 10 tells you how many zeros the number has. Okay, tell your partner. And then get ready for your next page of notes. Okay, the notes that we just did, powers of 10, base 10, I want you to put another like subtitle here. This is multiplying by 10. Oops, multiplying for. I meant multiplying by. Okay, multiplying by 10. So in that case, the exponent was increasing and increasing every time we multiplied by 10. Now I'll show you that the opposite happens when you divide by 10. Divide by 10. Okay, we're still talking about only powers of 10. But I'm going to start with a large number, and then I'm going to keep dividing by 10. So I'll start with 1 million, which is equal to 10 to the 6th power. And I'm going to divide by 10. So let me do it this way, okay? And in this, there we go. This is my input. We might as well make this a review of input-output functions, right? Input, and then my output is divided by 10. I'm going to take my input, I'm going to divide by 10 to get the output. Okay, so what is 10 to the 6th divided by 10? I'm going to write this one out to help you see that it's 10 to the 6th is 10 times 10 times 10 times 10, 1, 2, 3, 4, times 10 times 10, right? 10 to the 6th in expanded form is 10 times 10 times 10 times 10 times 10 times 10. We're multiplying 10 times. And I'm saying, let's divide that by 10. Now divide by 10, what happens? If you're good at fractions and factors, you easily remember that one of the 10s is going to cancel out because 10 divided by itself, 10 divided by 10 equals 1. So this equals 1. It cancels out because 1 times anything is the same number. So what we're left with is 10 times 10 times 10 times 10 times 10. We're left with 5 tens being multiplied. And that equals 10 to the 5th power. Okay, let's keep going. Now I'm going to take that 10 to the 5th power, and I'm going to divide that by 5. So 10 to the 5th power, and then go to the output. We're going to divide that by 5. I'll write it out. 10 times 10 times 10 times 10 times 10. There's 10 to the 5th, and I'm going to divide that by 10. And then just same thing as before. This 10 in the numerator divided by this 10 in the denominator equals 1. And the 1 times the rest of the number doesn't change the rest of the number. 1 times anything is the same number. So what I'm left with is 10 to the 4th. I'm only going to do this one more time, and then you should recognize a pattern. So I'll take 10 to the 4th, which is 10,000, and I'm going to divide that by 1. So I'll write it out to show it. 10 times 10 times 10 times 10 divided by 10. One of the 10s in the numerator cancels out with the 10 in the denominator because 10 divided by 10 equals 1. So if this equals 1, then 1 times the rest of the number doesn't change the value. Now you see that's 10 to the 3rd. What is happening every time we divide by 10? Pause the video and see if you can figure out the pattern. Pause the video. Okay, every time you divide by 10, your exponent decreases by 1. If we were to keep going, 10 to the 3rd, that's what we got here. Every time you divide by 10, you take away one of the zeros, and the exponent reduces. Let me try something different, very similar, but a little different. Now, how about if I'll go back to 1 million, and let's say that I divide by 1,000. Okay, 1 million divided by 1,000. I'm going to write this again in exponential notation. That's 10 to the 6th divided by 10 to the 3rd. Now I'm going to write this out in expanded form. 10 times 10 times 10 times 10 times 10 times 10. That's 10 to the 6th divided by 10 to the 3rd. 10 times 10 times 10. Okay, pause the video, write this on your paper, and then I want you to get the answer. Remember, the answer is standard form. So what is 1 million divided by 1,000? What is the answer? Okay, did you discuss it with another person? You should have paused the video and had an answer on your own. Don't just wait for me to explain everything. If you try on your own, it's going to make a lot more sense, even if you were wrong, because my explanation will have meaning to you if you're invested in this. If you're just sitting there listening, like copying, it's not going to be as important to you. So try on your own. Okay, using the expanded form, you can see the 10s that cancel out. This 10 divided by 10 equals 1, and this 10 divided by 10 equals 1, and this 10 divided by 10 equals 1, and we're left with 10 times 10 times 10, and you know that's 10 to the power of 3 because the 10 is multiplied 2 more times. So 10 to the power of 3 is the answer. In standard form, that's 10, and then put on 2 more zeros, 1,000. But remember what I taught you last time? That when you divide the same base, you can subtract the exponents. Let me say that again. When you divide the same base, you can just subtract the exponents. So 10 to the 6th divided by 10 to the 3rd equals 10 to the 6th minus 3, that's 10 to the 3rd. And we proved that by writing it out in expanded notation. Let me summarize dividing by 10. As the power of 10 decreases, 10 to the 6th, 10 to the 5th, 10 to the 4th, 10 to the 3rd, we're just taking away a 0 every time. Take away a 0 every time. Okay, those are the notes that you need that will help you do lesson number 2. So go ahead and take just a minute break, 1 minute, and then get ready for your assignment.